Hello students, I hope you are all fine. Due to COVID-19, I have recorded this lecture. So in your optics unit, the syllabus is interference, diffraction and polarization. Interference is Professor Prahlad will take the interference topic. Myself Anup is taking diffraction, and probably the Professor Ankur will take the polarization. So let's start with the diffraction. So in the diffraction you will learn the diffraction of light waves, Fraunhofer diffraction at a single slit, two slit and n slit, diffraction grating, resolving power, Rayleigh criterion and Fresnel diffraction. Okay, so in the diffraction there will be a introduction, single slit diffraction, double slit diffraction, n slit diffraction, diffraction grating and resolving power. Here you can see the image of CD. Why? Because CD has the characteristics of an optical grating. How? The CD has the microscopic pits which carry the information. These pits placed at equal distance and equal width on the mirror surface of the CD. It means, what does it mean? It means these pits is nothing but the number of slits which are placed equal distance and equal widths, and from there you can find out the incident light wavelength. Okay, so here is the CD, and if you see, there is a lines. These lines are nothing but the slits, number of slits, and their number of slits you can get the path difference, and you can get the, from the path difference you can get the wavelength of the light. So that is one application of the diffraction. Okay, so one of the great scientists, Richard Feynman, is already tell us no one has ever been able to define the difference between the interference and the diffraction satisfactorily. It is just a question of usage, and there is no specific important physical difference between them. The best what we can do is, roughly speaking, is to say that when there are only few sources, for example, if in the interference there are two sources, then the result is usually called the interference. But if there is a large number of them, it seems to that the word diffractions are more often used. Like the interference, it happens from the point source. Like you have already learned, from the point to point source, it can generate the waves, and from the that waves can generate interference, destructive interference and constructive interference. But from the diffraction, there are certain area, but again it area contains number of individual points. that is Huygens wavelets, secondary wavelets. So it can create the diffraction. Okay, so let's consider a plane wave incident on a narrow slit P. So according to geometrical optics, the region AB has to be illuminated and remaining region is completely dark. It means it is geometrical shadow. Further, if we do the careful observation, it shows that the width of the slit is not very large as compared to the wavelength of the light. The light intensity in the region here AB is not uniform, but there is also some intensity inside it, or the geometrical shadow. Some intensity lying inside the geometrical shadow. It means if the width of the slit made smaller, width of the slit made smaller, larger amount of energy reached the geometrical shadow. And this spreading out of the wave when passes through a narrow opening is usually called the diffraction, and intensity distribution on the screen is known as diffraction pattern. Huygens principle. Okay, so it's very necessary to understand Huygens principle. Then we will go to the single slit diffraction. So Huygens principle, it described the progress of wavefront, the progress of wavefront in a medium. Suppose this wavefront, this is spherical wavefront, is representing A, B. Suppose here A point and here is the B point. Okay. So this AB spherical wavefront is time t is equal to 0, and according to Huygens principle, every point on the given wavefront act as a source. Given wavefront act as a source of the secondary wavelets, which spread out with the speed of light. Every point is act as a source of the secondary wavelets, which spread out at the speed of light, and up to t is equal Huygens principle. Actually, Huygens principle described the progress of a wavefront in a medium. Suppose this is the AB front wave. So each point act as a source and it can generate the another wavefront. You can see here. So if we this AB is represent a spherical wavefront at time t is equal to 0, and according to this principle, every point on the given wavefront act as a source of the secondary wavelets, which spread out with the speed of light, and the new wavefront is the forward envelope of the secondary wavelets generate. So if the source is at the large distance, this source it is at the large distance, this wavefront is not the spherical but it is a plane wavefront. Okay, there is a two type of diffraction, Fresnel diffraction and Fraunhofer diffraction. In the Fresnel diffraction, there is source and the screen is kept finite distance from the diffracting aperture, whereas in the Fraunhofer diffraction, the source and the screen is kept at infinite distance from the diffracting aperture. And in the Fraunhofer diffraction, we have taken two lenses, two convex lenses. You need to cap the source lens L1 focal point, and you need to keep or kept the screen at the focal point of the lens L2. So you can generate the infinite distance from the diffracting aperture. And fractional diffraction is the most general case, whereas the Fraunhofer diffraction is the special case. And Fraunhofer diffraction is much simpler. The correct interpretation of the diffraction phenomena is given by Fresnel itself. That is due to mutual interference of the secondary wavelets. Now you know what is the secondary wavelets. Due to mutual interference, the secondary wavelets originating from the various points of the wavefront, which is not blocked by the obstacles, And here is what is the difference between the interference and diffraction is given some few points. In the interference, the interaction takes place between the secondary wavelets originating from the two coherent sources. While in the case of diffraction, interaction take place between the secondary wavelets originating from the different points of the same wavefront, which is different points but the same wavefront. But in the interference, there are two coherent different sources, but here different points from the same wavefront. In the interference, the region of minimum is perfectly dark, whereas in the diffraction it is not the same intensity. You can see here the central maximum, then the secondary maximum, then the second secondary maximum. So region is not perfectly dark in the diffraction. Okay, another difference is in the interference superposition of wave coming out from number of point sources. Okay, we have taken 2 point sources in the interference, right? From the 2 point sources interference happen, but in the diffraction happens, it's area of the sources. It means diffraction corresponds to the situation when we consider waves coming out from an area of the sources. Like suppose this is the area and the wavefront, each point acts as a source. Like Huygen's principle, each point acts as a source and it can generate the another wavefront. Okay, so it area of the sources. So these are the main differences between the interference and the diffraction. Okay, single slit diffraction. In the single slit diffraction, here you can see the source S is perpendicular to the plane of the paper, which is the monochromatic source. Lens L1 is the collimated by the monochromatic light. Sorry, lens L1 is collimatic lens, and AB, this AB is the slit of the width A. XY is the incident spherical wavefront. The light passing through the slit AB is the incident on lens, convex lens L2, and finally these rays refracted and reach at point P. A plane wavefront is incident on the slit AB, and each point on this wavefront is act as a source of the secondary disturbance. These secondary waves traveling in the direction parallel to OP, AQ and BV come to focus at point P, and bright central fringe observed here. The secondary waves from points equidistant, this one secondary points, this OA and OB is situated at upper part and the lower part. It is also traveled the same distance and reaching the point P. Hence the phase difference for this one is a 0. The secondary waves reinforce one another, and P will be a point of maximum intensity. Now consider the secondary waves traveling in the direction AR at an angle theta to the direction of OP and reach the point P prime on the screen. The P prime will be minimum or maximum intensity depending on the path difference between the secondary waves. OC, this OC and BL both are perpendicular to the AR. Okay, so if we take the sine theta opposite divided by width of the slit A. So triangle ABL and sine theta is equal to AL upon AB. So AB is the width of the slit. So AL divided by AB. So AL divided by A. So path difference AL is equal to A sine theta, where A is the width of the slit and AL is the path difference between the secondary waves originating from the point A and B. If the path difference is equal to lambda, the wavelength of light used, then P will be the point of, P prime, here P prime will be the point of minimum intensity. Here P prime is the minimum intensity. The wavelength is lambda, because if we consider the two halves OA and OB, it means lambda by 2, and here is lambda by 2. It's two part, right? Lambda by 2 and lambda by 2. It means for every point in upper half, OA, there is a corresponding point in lower half OB, right? Therefore, the path difference of these waves is lambda by 2. Wall is lambda, so this is lambda by 2, lambda by 2. Okay. We have divided here in two part OA and OB. We if we divide this portion into three part. Why three part? Because first we consider here means point source, here one and here one, two. But if we consider a three, means three part, one, two, so this one, two, three part. So three part means first part lambda by 2, second part lambda by 2, third part lambda by 2. So this lambda by 2 will cancel out, and one lambda remaining lambda by 2. From that lambda by 2, the point from that lambda by 2, constructive interference happen and bright fringes we can see, right? So but right now we have taken OA first half and this is second half, so lambda by 2 and lambda by 2. Okay, so lambda by 2 will cancel out. We got here the minimum intensity. If we take the 3 part, we will get the maximum intensity. It means the wavelength is lambda. If it is 2 lambda, 3 lambda, 4 lambda, the intensity will be minimum and its destructive interference. Thus the destructive interference takes place and the point P prime will be the minimum intensity. Okay. Thus the condition A sin theta n is equal to n lambda. A sin theta n is equal to n lambda for the destructive interference, where theta n gives the direction of the nth minimum, n is integer. If the path difference is odd multiplier, odd multiplies, it means 3 lambda by 2, 5 lambda by 2, 7 lambda by 2, you will get the maxima, means constructive interference.